Hello friends, welcome to our channel Knowledge Amplifier. So today we are back with another very interesting concept related to data engineering world, and that is fuzzy string matching. And this particular concept is very useful if you want to detect approximate duplicate records instead of exact duplicate records in your table, right? So especially in data cleaning phase or data curation phase, this particular thing is very useful. For example, someone is writing HERT and someone is writing HURT. So although these two are not exactly same, but they are approximately duplicate, we can say, right? And maybe based on the business requirement, if this kind of approximate duplicate records or strings are coming, then you might need to drop the second string which is almost similar to the first one, and we might need to keep only the first occurrence of it, right? In solving those kind of problems, fuzzy string matching really helps us. So we are going to explore today in this video how from a Databricks delta table we can drop approximate duplicate records, but I will split this particular tutorial into two sections. In the first section we'll be exploring a little bit about the internal mechanism of this approximate duplicate record detection and a very important module called fuzzy wuzzy, which helps us in this kind of fuzzy string matching use cases, right? And in our second section we'll be jumping into Databricks delta table, and out of that we will try to detect approximate duplicate records. Okay, right? So without any further delay, let us directly jump into the first section where we'll be exploring the fundamental algorithm which works behind this approximate string matching and this fuzzy wuzzy module. Okay, so the base algorithm which works behind the fuzzy string matching is Levenshtein distance, or it is also called as minimum edit distance. Okay, so what is that? It is a popular metric used to measure distance between two strings. If the strings are approximately similar, then distance will be less, but if the distance is more, that means we can say they are not approximately similar. As simple as that. And now the question might be how it is calculated. It is calculated by counting number of edits required to transform one string to another. Okay, so we are having two strings, HERT and HURT. Now how many edits we might need to do in this string HERT to get HURT, right? If more number of edits are required, then we can say they are not similar. But if very less number of edits are required to convert HERT to HURT, then we can say they are approximately duplicate, right? And when I say edits, there are three kind of edits majorly. One is addition of a new letter, another one is removal of a letter, another thing is substitution. So let's try to understand with this example. Suppose we are having HERT and we want to calculate the minimum edit distance between these two words. So what we'll do, we will first take HERT, and then as I told you, these three major operations we can do as part of edit operation. So you can see easily here it is having length 5 but here 4. So obviously one letter we have to delete. So as a first step what they are doing, delete E. Okay, so E is deleted, so distance became 1, right? Initial distance was 0, now distance got incremented to 1. Now we are having HERT. Now from HERT to get HURT, all we can do is replace A with U. And in this step, we are doing kind of a substitution operation, right? What I have mentioned here. And due to substitution, we are getting HURT. So kind of two changes or two edits we have to do. So that's why total distance between these two words, we can say it is 2. Okay. So this is the fundamental algorithm which works behind the fuzzy string matching. And now we are having this beautiful module fuzzy wuzzy, which perform all this operation in the backend. We no need to write this complex algorithm from scratch, and it basically return a percentage value which varies from 0 to 100. If the value is close to 100, that means they are similar, almost similar. But if the value is closer to 1 or if the value is very less, that means we can say the similarity is very less between those two strings. Okay, so basically fuzzy wuzzy module return us how much similar those two words are with respect to percentage value. Higher percentage means highly similar, lower percentage means not so similar, right? As simple as that. And now without any further delay, we will directly install this module in our Google Colab notebook, and we will start exploring with two different dictionary. Okay, so as a first step what I am doing, I am importing fuzz from the fuzzy wuzzy module, and we are importing pandas also, because on data frame how to apply this particular module, that also I want to show you as one of the demo. That's why I am importing this one. And now here suppose we are having this kind of data where we are having a list with name user within which elements are basically dictionary. Okay, first dictionary is having key favorite cricketer, favorite snack, favorite city and favorite show. Second dictionary is also having the same set of keys. Okay, no difference, but in the value part there are little changes, they are not exactly same. For example, favorite cricketer, if you see here it is written Virat Kohli, but here it is written the Virat Kohli. Okay, the is added, right? Then favorite snack, here it is written chutney comma samosa, but here it is written samosa comma chutney. That means there are swapping or position change of words in between string, right? Then favorite city, here it is Bangalore, here it is Bengaluru. And then favorite show, I love watching Two Brother and a Girl on ZTV, but here it is written I love watching Two Brother and a Girl on ZTV, love that show. So here kind of I tried to take all possible examples where we can understand how fuzzy wuzzy's different methods help us. First use case is basically when there is some extra words available but rest are exactly same. Then there is swapping of words within sentence, and then I have taken another example where there is some difference between letters within a word, and the last one basically I have taken where if you see this sentence and this sentence is almost same, only thing is here multiple times same word is appearing, like love 2 times, here also again love, right? So how fuzzy wuzzy will behave in comparing these two, that also will be exploring, right? So here I will run these two, and the first basic method what fuzzy wuzzy provide for string comparison is ratio. So fuzzy module's ratio function basically expect two string to compare. So obviously we need to pass two strings as part of argument for this particular function, and what it returns the similarity of the sequencing of the strings. Okay, the value between 1 to 100. If it is close to 100, that means almost similar. If it is close to 1, that means not so similar. And here what we are doing, we are performing comparison between same keys taken from this dictionary as well as this dictionary. Okay, so here you can see print fuzz.ratio. So like this way we can call, and first I want to compare what is the similarity between favorite cricketer key taken from these two dictionary. So because these two dictionaries are within list, so users of 0, that way I am extracting first dictionary, which is basically first element of this users list, and there I am applying dot get method to extract the value of favorite cricketer from this dictionary, right? And same goes for second dictionary as well. Like that way I am performing fuzzy string matching for all the keys available in these two dictionary. So let's run this one, and here it will return these values. Okay, so if you see for the favorite cricketer, the similarity score is 74, Virat Kohli and the Virat Kohli, right? Only the is added, that's why it is having little dissimilarity. But if you see chutney samosa and samosa chutney, here lot of cuts or changes or edits we might have to do to convert from chutney samosa to samosa chutney, right? That's why its score is less, right? And then favorite city, Bangalore, Bengaluru, there are lot of edits in between letters or swaps in between letters, that's why 67. And then favorite show, here although they are conveying same message but it is having much more length, so lot of deletes we have to do, that's why it is not very less but it is not very high also, that we can say that they are exact duplicate, that's why score is 70, right? So fuzzy's ratio function kind of return this kind of response. Now let's see for the same input how other functions whatever provided by fuzzy module help us. So fuzzy module's partial ratio function is there, which expect two string to compare, and again it also return value between 1 to 100, but it don't compare how this ratio function compare, but rather it compare closest matching substring. Instead of doing exact string comparison, it compare based on closest matching substring. So for example, if you consider Virat Kohli is exactly available as a substring in this dictionary as well, only thing is the is added in this particular value, that's why initially when we were applying ratio it was giving us 74. But if we are doing substring level matching, then favorite cricketer from first dictionary and favorite cricketer from second dictionary will be exactly matching, because Virat Kohli is available here as well, right? So when we will apply partial ratio, we can expect that for the first key, that is favorite cricketer comparison, we should get some higher value. Earlier we are getting 74, but this time we should be getting more outcome, and that's what we are getting here. Now we are getting 82. 82 meaning the favorite cricketer value from the first dictionary and second dictionary are very close, almost similar, right? So you can understand like this way, it compare substring level instead of complete string level. That's the advantage of partial ratio. Now let's go to the next function, which is token sort ratio. So what token sort ratio does is basically it also compare two string, but compare despite word ordering. For example, here it is written chutney samosa, but here it is written samosa chutney. If you think, if we sort these tokens which are available within the value for a particular key, and then if we compare, that means if ordering can be avoided somehow while doing comparison, then favorite snack from first dictionary and second dictionary will be almost same, right? That's where the token sort ratio function helps us in comparing two strings irrespective of their word ordering. For example, I like dogs and cats and I like cats and dogs will have very high similarity score if you are applying token sort ratio function from fuzzy module. And let's inspect that. So I will run this one, and if you see favorite snack, for that, due to application of token sort ratio, it is returning that these two strings are highly similar. Similarity score is 97. And why this is happening? Because here it is written chutney samosa and here it is written samosa chutney. So that means if we sort it and then compare, it will be exactly same. That means highly similar. That's why here in this case, we are getting 97 as similarity score, right? For others, it is not so high value because sorting is not helping us in those cases. And the next very important function what we are going to explore is token set ratio. What it does, it also perform the similarity score between two strings and return the value between 0 to 100. But this function's advantage is it compare set level tokens, not directly string level. So for example, if you consider this one, I love watching two brother and a girl on ZTV, and here it is having that same kind of information, almost same we can say, but love two times, right? Again here love another time, right? So kind of in a way we can say that if we take set value of the tokens from these two strings and then compare, then we'll be having higher similarity between favorites, so right? And if you want to compare like that way on a set level for the tokens from the string, then you can take help of token set ratio. And let's run this one and let's see how it is returning for favorite so. If you observe for favorite so, it is returning 92. Very high score. For earlier ones it was 75 less, then 73 and then 70. For everywhere it was less because same kind of tokens were repetitive like love, etc. But when we are using token set ratio, that time we are getting highest similarity score because they are comparing on token set level instead of comparing the exact string, right? That's the advantage of fuzzy modules token set ratio. So token sort, token set, ratio, partial ratio. These are four major important way of comparison, and now I hope you understood up to this, and based on business requirement you can pick up one specific function which suits your use case best and apply to detect approximate duplicate records, right? And now I want to show you another important and very useful functionality provided by fuzzy module, that is process. So what this process does, this is great if you have a limited amount of choices or options and messy data. So let's consider one example. Suppose I am having only 4 choices, yes, no, maybe and NA, right? And now you are getting various inputs, maybe from some user feedback or something, and that you want to standardize out of these 4 possible values. Whatever is nearest matching, that you want to pick up so that the data within your table will be standardized and it can be consumed in an easier manner by the downstream application. Suppose that kind of thing you want to do. That time this process function can help us. So here is the code from fuzzy wuzzy import process, and suppose we are having only these 4 possible choices. So suppose user is putting yeah as input. Now from the manual inspection you can say this yeah is having highest similarity with yes, so that means we can map this yeah to yes, right? But in a programmatic manner if you want to do, you can take help of process.extract. Okay, First you need to pass the user input which you want to map out of these 4 possible choices, and then you have to pass what are the choices or options you have as a standardized value. For example, this list I am having, that I am passing a second argument, and then limit 2 or limit 3 you can pass. So if you are putting limit 2, that time what it will do, this process.extract will return 2 highest similar choices out of these 4. So that's what I have written here as a comment, that return 2 possible matches from the list of choices we have declared in our choice variable, right? So if we run this one, let's see, here it will return yes is highest similarity 45, and then maybe also it is very closely similar, that also 45. But suppose in some use case you want to get the highest similar one, instead of getting 2 or 3 similar choices, you can take help of extract one function or method instead of extract. Okay, and here you need to only pass user input and the possible set of choices. No need to pass how many rows you want to get using limit clause. And if you run this one, here you will get that with user input yeah, the highest similar choice is yes. Okay, then similarly you can take some other example. For example, if user is passing nope, then you will see that it is having highest similarity with existing data no with 90% similarity score, and then the next similar outcome is yes with only 29 similarity. So from here you can easily say that no should be mapped to no. And if you want to get only one row, you can extract process.extract1, you will get only no, right? The application, if you consider in real world data cleaning process, there you can extend the same concept in pandas data frame or PySpark UDF as well. For example, in a pandas data frame, I am having a city column with the user input New York, San Francisco, Chicago, etc. But New York, it is not completely written, it is just NW York. But suppose you want to standardize this, and here in a list you have defined possible set of city values. New York completely you have written, then San Francisco, it should not be SN, and then Chicago spelling also you have corrected. And now suppose these user inputs or user cities you want to standardize. That time what you can do, you can easily apply this particular process.exact1 function on top of your pandas column, that is city column, df of city equal to df of city dot apply process.extract1, and then I am basically passing the value from the city column and then the possible set of values whatever we have defined in the correct names. And if you see this extract1 function, it basically return a tuple. So I am not interested in score, I am only interested with the first value. That's why I am applying process.extract1 of 0 to get only the most similar item instead of getting the score value as well. And then I am printing data frame after spell correction is print data frame. So let's run this to understand how it is working. So our original user input looks like this, where different users tried to write their city names differently, but here using process.extract1 we have standardized and corrected this spelling: city, New York, San Francisco and Chicago, right? So this is how in spelling correction or standardization use case process.extract1 or process.extract can help us, right? I hope you got this. With this, the fundamental understanding of fuzzy wuzzy module, I hope it is clear to you. Now we will scale this and we will apply in Spark data frame approximate duplicate rows detection in our next section. Till then, try to practice this particular section's lab. The notebook link I'll be providing in the description box. Try to play with it, that way you will be understanding in a better way. We'll catch up in the next section. Stay tuned. So welcome back to our second section of this video's discussion, where we are going to explore how to detect approximate duplicate records in a table using weighted fuzzy logic. Okay, so here I'll be executing this demo in Databricks because I am going to use PySpark. And to start the demo, first we'll be installing fuzzy wuzzy in our Databricks cluster. So once that will be done, we need to restart the Python to use it properly. And then here what I am doing, I am importing some important modules whatever required for this experiment from PySpark, as well as from fuzzy wuzzy import fuzz we are doing, right? And now let's have a glimpse of our data set on which we have to apply approximate duplicate rows detection. So if you see here, we are having varieties of use cases. First case is same person but little bit name and address variation. For example, via some forms we are collecting user information, and maybe that time due to manual entry some little bit spelling changes would have happened. For example, row ID 1 or customer ID 1 is having name Cody Johnson. Customer ID 2 is also having Cody Johnson, only H is missing here, right? And if you see the address line, this one and the second address line, there is very slight difference. For example, here only one F is there, here 2F is there. And here the spelling is BRAC, here the spelling is BRACE, right? So that means we can at least understand that these two are same person from the human understanding itself. Similarly, for the third customer ID, if you see, it is also Cody Johnson, only C is replaced with K, right? That is the only difference. So on the name as well as on the address, we might need to apply some fuzzy logic, and both of the columns we should be considering while trying to detect whether they are approximately duplicate or not, right? Then second case can be same person but slightly different address. If you see now the name is same, right? But address, if you see, it is 3 by 752, but this is only 752. So not only name, we should be focusing on address also in this example. Then third case can be different people, same address. So here the name of the customer itself completely different. They are different guys, but they are staying in same address maybe, right? So in this case, address's importance is less, but rather we should be giving more importance on the name, correct? Then there can be some edge case where same customer might have entered the information 2 times. So this is exact duplicate, right? And then next case can be same name but different people. So if you see, the name is exactly same, but maybe there are 2 different people who are staying in 2 different places, right? 2 different addresses. Okay. So these all possibilities might come in our real world projects. It is not like in our earlier demo how we have applied fuzzy ratio or fuzzy partial ratio only on 2 strings. That might not happen only on 2 strings to detect whether they are approximately duplicate or not. In our real world projects, this might not be as simple as this one. We might need to consider more than one factor or columns, like here name, address, and then maybe postal code also, right? Like this way, multiple columns we might need to consider while having approximate duplicate detection. That's what I am trying to say. So here the column names are ID, name, age, address line, city, postal code, state. Okay, so I'll be creating the data frame quickly. And here we are having our beautiful data, where ID, name, age, address line, city, postal code, states, etc. are there. And as of now, what we can do, we can maybe focus more on name, address line, city and postal code. These 4 columns for approximate duplicate detection. You can confirm from business team anytime that what all columns we should be considering for approximate duplicate detection. But for this POC, let's consider that we should be only considering these 4 factors: name, address line, city and postal code, okay, which latter we'll be using in our code. So keep in mind as of now. Now what we need to do, we need to compare the data, whether the first row is matching with some other row or not. Matching in the sense not exactly matching, but approximately matching or not. Like for example, the ID 1 is almost approximately matching with ID 2. Just only H is missing in the name, and here double F is there in the address line, but here only one F is there. So from the human inspection itself, we can say that these 2 rows are approximately duplicate, right? But that we have to decide programmatically. And for programmatic detection, we need to use this fuzzy wuzzy module. But fuzzy wuzzy module require 2 strings based on which we need to compare. But here one row is available in the first line, another row to be compared is available in the second line. So this way fuzzy wuzzy cannot compare. What we have to do for comparison purpose, the another row also we have to bring in the same row. Like for example, this particular row ID 2, I have to bring somewhere in row ID 1 only, in some new column maybe. That way we can apply fuzzy wuzzy on this row ID 1's column as well as row ID's 2 column, which is available in the same row, and that way comparison will be possible. So obviously what we need to do to bring this particular row along with first row's combination, or maybe to generate all possible permutation combination, we have to apply cross join. So that we will be doing, that is compare every customer with every other customer. So for that purpose, what we will be performing, we will be performing cross join. If you see the join code, dfa dot join dfb. Okay, so dfb basically here I have given for the same data frame alias name A and B, and the join clause is not mentioned. Only thing what I am mentioning is a.id not equal to b.id, because it does not make sense that ID1 I'll be comparing with itself. If we apply cross join, then ID1 will be having a pair with ID1 itself, but that one I don't want. I want to compare one particular row with all other possible rows, right? So that's why I am giving this clause a.id not equal to b.id. So now how our structure will look like, let us try to understand. Maybe pairs dot order by, here I can write like this way, so that way we can easily understand the data, and let's run it now. So this is how our current data looks like. If you see, ID1 Cody Johnson is having now 10 rows for the same ID1. Why this is happening? This is happening because here if you see in our original data we are having 11 rows, and we have applied cross join but excluded same row comparison thing using the clause a.id not equal to b.id. So that means this ID1 will be having rows for all other 10 rows. This ID2 will be having rows for all other below 9 and above 1, total 10 apart from itself, right? So that way for each ID will be having total 10 combination with all other possible rows, and that's what is happening here. If you see here ID1, let's inspect. So this is basically data coming from the actual table, but due to join here ID2 is coming, ID2 Cody Johnson, and with double F the address line, and here H missing in the name, ID2 came. Now for the same ID1, ID3 came, ID4 came, 5 came, 6 came, 7, 8, 9, 10, 11. Then again here if you see that our ID2 is starting, and then ID2 is going till 10 rows, and if you check their right hand side, here it is having rows with 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because we are working currently with row ID2, that's why apart from ID2 with all other possible rows we are having its combination, because we are applying cross join with that clause a.id not equal to b.id, right? Perfect. And now I hope you are getting this, what we are going to do. We can simply perform fuzzy matching between this name and this name, then fuzzy matching between this address line and here this address line, then this city and here also this city, this postal code and here this postal code, right? So this way now we'll be comparing multiple columns we have to consider while similarity detection, not only one column, right? That is the ultimate goal, and that's where weighted fuzzy helps us instead of directly applying fuzzy. So what is weighted fuzzy? It is nothing new. Here we are having more confidence in some column of our data than others. Therefore, we want to prioritize the similarity result by adding a simple scaling factor. If you see the code, you will be understanding it easily. We are just applying fast.partial ratio only between maybe name, and then address and address, postal code and postal code. Only thing is maybe name similarity we want to prioritize compared to postal code similarity. So to do that programmatically, here what we are doing, we are giving some weights. So for example, business is saying on the name column you apply more focus, you give 0.4 as weight. For the address also you give more focus, maybe you give 0.4 as weight, or maybe address little bit more weight and name little bit less. So on the name similarity 0.3 weightage, on the address similarity 0.5 weightage, and then on the city similarity maybe 0.1, and on the postal code maybe 0.1. So this is how distribution can happen, that is across multiple columns. If you have to find out similarity, then the best option is defining the weights and then calculate partial ratio using fuzzy wuzzy module between those columns and multiply by the respective weights. So that way we can give more confidence on some specific columns on our dataset than others. Like in this case, postal code is having lesser importance than address line. So that's why we are distributing the weights like this. And again, this weights distribution also business team can help you in deciding these factors. Okay, based on your business requirement, it might vary. So what we are going to do, this particular user defined function we are going to register, and this one will be using in similarity score detection. So now here what we are going to do, pairs data frame already we have created, which is having basically our Cartesian product or cross join between all possible combination apart from itself. And now what we are going to do, we want to apply that fuzzy UDF, that is this particular user defined function, whatever we have registered based on this weighted score function, that one we are applying, but on these 4 columns from our data frame. Name, address line, city, postal code, and then again name, address line, city, postal code. So here maybe this will be b dot postal code. So already in the pairs column our A and B both are available, because here we have given the alias name, right? So based on that we can select like this way here. Cool. And then here we can run the similarity score and let's see how our data looks like. Our data now looks like this, which is almost similar like our previous pairs data frame. Only thing is one new column is added, similarity. If they are highly similar, their similarity score will be towards 100, just like in our earlier demo we have seen. But if they are not similar, their similarity score will be towards 1, that is 31 or less, right? For example, if you see this first Cody Johnson, and then this is the address line, and if you scroll little right, Cody Johnson only H is missing and here double F is coming, but overall we are getting the sense that they are approximately duplicate rows, right? That's why here similarity score is very high, 93, right? But another row, if you consider this row ID 3, let's go there. Here the name is Cody Johnson, right? And what is the another name we are trying to match here? That is Angela Watson. Cody Johnson, Angela Watson, not at all matching. Then address line for Angela Watson is 3 by 752 like this. But for Cody Johnson, the address line is this Jeffrey Bruck, something like that, right? So not at all matching. That's why their similarity score is very less, right? So now we are having this similarity column, which is giving us a sufficiently good idea that row ID 1 and row ID 2 are approximately duplicate, but row ID 1 and row ID 4 are not at all similar. They are different rows, right? So this column is very vital in detecting approximate duplicate. And now the next step should be, we need to group approximate duplicate rows together. That is, there should be some column which will have same value for approximate duplicate rows, but it will have different values if the rows are different, if they are not approximately duplicate, or if they are not matching with some other rows available in our data frame or table, right? So now we'll be deriving that thing and intuitively try to understand how we can do that. So here if you see, ID 1 is there and then ID 2 is there, they are approximately matching, their similarity score is 93, very high. So we can derive maybe an algorithm like this, that if similarity score is greater than 80, then whatever minimum ID is there, that you put in that column, in that new column, which will be having same value for almost similar rows. So what I'm saying, ID 1 is there and with this ID 2 is matching. So 1 and 2 both are matching, their score is greater than 80. That time what I can do, I can put ID 1 value in that new column. Okay. So whatever is lower ID, that one will be putting. So that way what will happen, you know, that when in this row we'll be comparing for ID 2 Cody Johnson, it is also having high similarity with ID 1 Cody Johnson. So in between ID 2 and ID 1, what is the lower value? That is 1. So for that new column, again here also it will be taking the value 1. So that way it will basically converge to the grouping of similar rows, right? That is the main point. So the algorithm is, if the similarity score is greater than 80, you take the lower value of the ID column, whatever available in our specific row. We are having two ID column, right? One is A.ID, one is B.ID. Whatever is lower, put that directly there. And if the similarity score is lesser than 80, then whatever original ID is there, that is A.ID, that alone you put. No need to consider B.ID. So let's see if we kind of apply that kind of code, what will happen. So here I have written that kind of code, that if similarity score is greater than 80, then whatever lower value between A.ID and B.ID, take that one. Otherwise, if the similarity score is lesser than 80, you just simply take A.ID, that is original ID. And that way we will be getting this kind of data. If I scroll right, here you will see some sort of grouping is happening here. Try to understand how it is happening. For example, first row if you consider Cody Johnson, it is having very high similarity with ID 2 Cody Johnson as well. And that's why here group ID we are getting 1. Similarly, if you see this particular actual row ID 2 Cody Johnson, it is having very high similarity with row 1 of Cody Johnson. For that also we are getting group ID 1, right? So that way they are little bit converged. But there is a problem, slight problem, that is when the row ID 2 Cody Johnson is getting compared with row ID 3 Cody Johnson. Try to understand what is happening. There is row ID 2 Cody Johnson is available here, and if I scroll little right, here row ID 3 is also having Cody Johnson. When between 2 and 3 the comparison is happening, the similarity score, if you observe for this row, it is 97. But in between 2 and 3, what is the minimum ID? In between 2 and 3, the minimum ID is 2. That's why it is taking the group ID 2, right? So for the same row, Cody Johnson with ID 2, sometime we are getting group ID 1, sometime we are getting group ID 2, right? Because always it is not having comparison with the first row. It can have comparison with some other row as well, correct? So now what we have to do, we have to standardize this, and that is very simple. What we can say that if for a particular row we are having multiple group ID, take the minimum group ID value. That way we will be having only one group ID for one specific row, and that's what we are doing here. First we are selecting only the required columns. We can just avoid the columns from the B table, which is basically same table but we have given alias name. Only A related columns we have extracted, and then here I am simply applying a partitioning on ID and order by group ID, and then applying rank. For the rank equal to 1 alone, the rows you pick up. Okay, so if you see now the data, observe here, it is having only 11 rows as of our actual data, but Cody Johnson, address line also same. If you see their group ID, they are only 111, right? Then here Angela Watson, if you see these two Angela Watson having different address, but name wise and other things wise like city or postal code wise they are almost same. Their group ID is also same, 44. If you consider these rows, Liam Smith, and their address also same, they are exactly same rows, kind of duplicate rows, their group ID is also same. And then the last case, if you consider Cherise Brown, but their address line is completely different, but although city, postal code and name are same, but maybe they are two different guys with same name staying in two different place, but because we have applied weighted fuzzy, if you see their group ID, they are different 10 and 11, right? So this is how, by applying windows and then taking minimum ID after applying cross join and fuzzy string matching, we can basically group almost duplicate rows with similar kind of IDs, right? And now I hope once you get this kind of column, you can easily perform data processing. I can understand that this transformation, whatever I have discussed, is little bit complex. I'll suggest you to have some dry run, try to change some values and run in Databricks cluster, try to apply as many display command as you want to understand how it is working. You'll be getting better feeling out of it. But this is a very powerful algorithm to detect approximate duplicate customer base or maybe this kind of similar entity matching use cases, right? This is all for this video. I'll be providing this code also in the description box. Try to play with it. You will be getting better idea out of it. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.